Hello everyone, I am Amit Ami and I'm here to present MASC with Said and Redwan. MASC is a tool for mutation-based evaluation of static crypto API misuse detectors. This demonstration paper is the result of collaboration between the researchers of William and Mary, George Mason University and University of Dhaka.
The goal is to intelligently generate mutants, which can be used to conduct mutation testing on crypto detectors in order to evaluate and benchmark them. MASC makes it easy with the help of misuse cases, mutation operators, and mutation scopes. Misuse cases are ways that compromise the security of an application. For example, using weak encryption algorithm, using RSA with a small key size, and not using salts when hashing passwords are examples of misuse cases taken from the data-driven taxonomy of misuse cases that powers MASC. Now, these misuse cases can appear in real life in many different ways. For example, this is one way a weak encryption algorithm might be used. This is another way passing the argument in lower caps, and this is another way passing the argument in a variable. Now, this is where mutation operators comes in. Mutation operators are transformation rules that generate insecure mutants by creating different representations or instantiations of a misuse case. In our case, the misuse case is weak encryption, and the mutation operators generate these representations and many more. Once these mutants are created, the next challenge is to insert them in real-world Java applications, which is where we need the mutation scopes. Now, there are three mutation scopes. The first is main scope, where the mutant is inserted in a bare-bones Java application. The similarity scope, where the mutant is inserted next to a similar API call, and the exhaustive scope, where the mutants are inserted in all locations allowed by Java syntax rules.
We shall now see what MASC web interface has to offer. Before starting to explore MASC web interface, we shall first upload our desired configuration files. Configuration files are mainly the settings which we want to include in our mutation. So let's upload a configuration file here. First, we have to provide a name and select the configuration file from our local machine. Here I have already created a configuration file in my local machine. I'll upload it in. Once the file is uploaded, it will be available for further updates and available for further usage. Here we can see the detailed view of the uploaded configuration file. The operator type has been declared as string operator. The target API is message digest. The method of invocation is getInstance. The secure parameter is SHA-512 and the insecure parameter is MD5. The scope for this configuration file is declared as main scope. If we feel that we need to make any changes to this file, we can update them and save the changes. And if we don't feel any changes should be made, then we can simply skip this part. To the next feature of MASC web interface, that is the MASC lab. MASC lab provides an environment where the users can test their configuration files and see what mutations are generated. Here I shall choose the configuration file which I have previously uploaded and submitted. Now it will provide me a detailed view of the configuration file. That is, we can see the operator type, API name, secure parameter, insecure parameter, etc. Any last minute changes can be made here. There is also an option to exclude any of the operators. There is a list of operators based on the operator type mentioned in the configuration file. As here it is string operator, we can see the list of string operators. The user can select any of the operators in order to exclude them from the mutation process. Let's select two of the operators and run MASC. Here we can see the generated output, and output has been generated only for the 4 operators which were not excluded from this process. And user can also download these results if they want. Now let's move on to the next feature, which is MASC engine. So MASC engine mainly provides us an interface where we can mutate our source code. Now we can select any of the properties here. MASC engine mainly runs based on exhaustive and similarity scope. So only the configuration files which have exhaustive or similarity as the scope is being displayed here. So let us select the similarity properties, submit the configuration. We need to give an app name. Let's say my app 124. Now we just have to select the source code that we want to mutate. So from choose file, I can select the source code for my local directory. Here I have uploaded my source code, and if I hit the Run MASC Engine button, it will start running MASC Engine on the background and generate the further results which are needed. Once the process is finished, the status will be updated here and it will be available for download. As we can see, the process has been finished. Now I can just hit the download button and the source code will be downloaded. That is the mutated source code. Here we can see the mutated source code has been downloaded. Moving on to the next feature, that is plugin managers. MASC provides the interface to integrate any kind of custom plugin into our mutations. I have to choose a Java plugin file. I have already created a Java plugin file here and I will upload it to the system. Once the Java file is uploaded, I can compile that file from the plugin manager project. Here I can see the compile button. If I hit the compile button, MASC web interface will compile the Java plugin file and create the plugin.class file, which will be available for further use. Here we can again visit the MASC lab portion and see the effects of the custom plugin. As it was a string type plugin, I will have to choose a configuration file which have the string type operators available. I'll exclude all the existing operators and run MASC flag. Here we can see that only the mutation for the custom plugin which we had uploaded was created, and the rest operators were excluded. If I go back and include all of the operators again and run MASC lab, then we can see that even here the mutations for the custom plugin were generated. Again, if I go back to the plugin manager and change the status of that plugin, that is, if I don't want to include this plugin in my mutation process anymore, I can just change the status to inactive state. Here we can see that the status is inactive. We can even further include it as well by changing the status. It provides an interface where the users can easily choose if they want to add a custom plugin or not. And that is the plugin manager feature. The last feature here which MASC web interface has to provide is tool profiling. Tool profiling is a fully automated process which gives the user the ability to run the mutation process and test a tool with the created mutants and generate results for the part. So for that, I need to choose the correct configuration file. So let's create a new configuration file from the configuration manager. I'll name it as automated analysis and choose the proper configuration file. I'll upload the configuration file and it will be saved to the configuration manager. I can inspect the file again from the configuration manager. And if I'm happy with it, I can run the mutation process. So let's get tool profiling and select the uploaded file, that is cipher.profiles. I can submit the configuration and inspect the configuration file here. From this configuration file, we can see that the scope is very small. We want to generate the mutants and the type of operators that will be used as string operators. The targeted API is Cipher API, and the method of invocation is getInstance. The secure parameter is AES, that is Java GCM, and the insecure parameter is also AES. The variable name is crypto variable, class name is crypto. We want to do automated analysis, and we also need to provide the information for the tool that we want to analyze. Here, the tool name is findsegbugs. The tool location, that is the on which directory the tool is saved in my current machine. The command that is needed for the tool, and the rest of the output directives and commands which shall be needed. Now we shall run the tool profiling process. Once we hit the run tool profiling process, MASC web interface starts running the process in the background. Here we can see that the process has already started. The status is running, and when the process will be finished, the status will be updated. We can refresh it from here. Then I can see that my status has been updated. I can inspect the results. Here I can see that we total had 7 mutants, that is 6 of the operators which were included by default, and the custom plugin because the status of the custom plugin was activated. Here we can see findsegbugs were able to detect two of the default operators, and also it was able to detect our custom plugin that we provided, but it was unable to detect four of the operators. Now, FindSec bugs has its own profile. If we visit that profile, then we can see the results of each of the automated analysis that we ran. This is the latest one. Thus, it provides an overall view of this crypto detector and also the results which it provided from time to time. Overall, this is the MASC web interface and the features which it provides.
This concludes the demonstration of MASC's web-based frontend. Additionally, MASC has a command line interface that offers all the functionalities shown here. MASC is completely open source and all the details, including extensive documentation for users and developers, are available in the URL shown here. We hope you enjoyed this demonstration and also hope that you will enjoy using MASC. Thank you for your time.